Good afternoon, everyone. My name is Sumit Kumar. I am a program manager in the C++ team at Microsoft. And today I'm going to talk about how do we make stunningly beautiful Windows Store apps using C++ and be it high performance and make it battery sipping so that your battery is conserved. How many of you here do not write C or C++ code on a day-to-day basis? About half of you. All right. All of you write Objective-C, I understand that. So you've been hearing all the great things about Windows Store apps and different technologies and different language and tool choices that you have. And you must be wondering, when do I use what and why use C++ and when use something else? One of the great things that Microsoft has done is we are coming and telling you developers that we will come meet you guys wherever you are. So if you have a web background, then we have provided you HTML5 JavaScript tooling stack for you to go build a Windows Store app very easily. If you come from .NET background, we have first-class tooling for that. If you happen to come from C background, we have first-class entire stack support for that as well. But depending on what choices you make, you have different strengths that those choices offer to you. I will talk about the strengths of C++. Okay? So before I actually go do more talking, let me show you an app that our team built to sort of to showcase the benefits of all the technologies that we have released in this release of Visual Studio 2012. So what I have here is a note-taking app, simple note-taking app. I have a stylus, and I can, so I have a app bar here. I can choose different pen thickness, and I can say, hi, iOS devs. Okay. You already saw that there are other things that are available in this app bar. I can add pages. I can choose different kinds of pages. I can add photos. I can take a photo from the camera, if it works. Okay. Yes. Okay. Then I go back, and I will have the picture here, or maybe not. Then I'll take a picture from the disk. Let's see. Let's take this picture, this app PC guy and Mac guy, and I can do things like hold on to this picture and rotate it, and then I can make notes here. So this is the Mac guy, and so on, right? I can browse through all the pages in a very fast way, like this. Okay. I can go back and do things like this. I can see different views of this. Okay, you already saw that. I can turn the pages like this. See how nice full 3D effect is used here, right? So since it's a Windows 8 Windows Store app, you have all these functionalities here. I can share things from here. So I can share this page in an email. So it just came here, right? And I can send it to myself. And it goes there, right? So it looks like a simple 2D page, but it is actually a full 3D scene being rendered as a simple page. So I can do a different angle here, and then I can do all of these things, and and I can then do full turning effect here. Okay, so it's a full 3D page. I can also do some animations if I want. I don't know why anyone would want to do that, but just because you can, you can do one more, different kind here, and you can also write on top of it, right? So just some coolness, right? So this is just to show some of the things that you can do in C++. I'll come back to this app right at the end when I've talked about these specific technologies, and then I'll show you how all of those things help here. So what am I going to talk about? C++ in respect to the Windows Store apps, and then I'll go talk a little bit about the new language extension that we have created for you to make it easy for you to go and easily target the Windows Runtime APIs. We're calling it C++ CX, the component extensions. And then I'll show some code and walk you through how do you use XAML and C++ together to make a very good, quick app. And then I'll talk about the bread and butter of C++, which is power and performance. What are the things that you can do to get the most juice out of the resources available to you? So going back to the topic of why C++. These are things true for all kinds of apps, but even for Windows Store apps, all of these three things hold together, right? So all the reasons can be grouped in these three buckets. First, I'll go from bottom. Compatibility. By compatibility, I mean a lot of things. Compatibility with your skills, I already talked about that. If you have been writing C++ code for years, you can bring those skills and you can bring those assets, and you can continue to build great apps. Compatibility with different languages, compatibility with Windows Runtime in this case, and because of that, you can write WinRT component DLLs in C++ and have it used with from other languages. In general, C++, more C than C++ is good at that, right? When programming language A wants to talk to programming language B, they talk to each other in C, right? Another thing which is very relevant and important for you guys is cross-platform. Portability. You have apps in one platform. You have, say, a game engine that you've written, game app that you've written, and the bulk of the compute happens in a component written in C++, and the UI happens in whatever language is native to your platform, Objective-C or Java, whatever it is. So you would like to use that C++ component in Windows 8 apps, you can bring that. That is one of the reasons why people use C++, right? And the fact that C++ is an ISO standard-based language helps you with that. There are multiple platforms that support it. There are multiple compilers that support it. All of those are good reasons to use C++. But the topmost reason is closeness to hardware. By that, I mean a lot of different things. People obviously know what the first one means, the performance, right? You want X amount of computation to happen in a very fast manner. So you use C++. C++ is very good at that. You want to efficiently use all the hardware that is available at your disposal. The tablet machines today are, parallel supercomputers, right? They have lots of cores. All of those cores have vector units in them. Many of them have GPUs, compute class GPUs. So there is so much computing juice available, but it's difficult to access all of that power through other languages and tools. C++ provides you access to all of that. C++ is also very good at enabling real-time experiences, real-life experiences, some of the things that you saw in the Austin app that I just showed. If you want to control the pixels on the screen directly, you can do that using C++ and DirectX. So those are the things that sort of summarize why you would use C++ to write Windows Store apps. So you've seen, I'll quickly build this thing. You've seen this Windows 8 programming model slide before, or some version of it. All that I'm trying to show here is C++ is pretty central. It doesn't show it very well here. So you can do XAML UI, XAML-based UI apps in C++. You can also write HTML JavaScript UI apps that call into C++ WinRT component DLLs for compute. And the third one is C++ and DirectX. You can talk to DirectX directly. So So with C++, you have access to all three programming models, UI programming models that Windows 8 has to offer. And the great thing about, another great thing about Windows Store apps is all of these WinRT APIs are all native APIs. So if you see, this is the old desktop world. C++ has always been powerful there. All of this is native. This is native. You can go XAML route through native. You can go HTML JavaScript route through native. So there is a lot of native power built into the stack. And the XAML that you see here is not the old .NET XAML. This is pure native implementation of XAML. So even if you're using XAML, you're not getting into any .NET stack. So just to summarize that slightly differently, all three programming models available for you in C++. A little bit about the tooling in Visual Studio. This is sort of a summary of everything that Visual Studio provides you to be very productive with creating great Windows Store apps very, very quickly. So there are a lot of different templates, item templates and project templates that are fully fledged applications in themselves. You just go there and you can get to a running app very quickly from there. Visual Studio Designer, for the first time, is available to C++ developers. We have never had any designer support. You can do that both in Visual Studio as well as in the Blend tool. Blend understands C++. You can build C++ code in Blend now. And the IDE experience, the editing experience, all the wonderful things that Visual Studio has to offer, all of that, that understands WinRT and concepts very well. It gives you very good completion. The object browser and all of that works very well. And we have created C++ CX extension to C++ language, which gives you a very natural mapping to WinRT APIs. Debugger support. One of the things, again, works very well for C++. One of the things that is missing from here is if you do a lot of graphics type apps and you have to debug in those kind of apps, we have very good graphics debugging and graphics related tooling in Visual Studio 2012 also. And other packaging, deploying, everything works very well with C++. Point of that slide was first class support in Visual Studio for C++ to write Windows Store apps. Changing gears a little bit. What is C++ CX? It is an extension. Basically, it's a binding to a foreign type system. That foreign type system happens to be the Windows runtime here. And Windows runtime, since it is based on COM, there is automatic reference counting. All of that is available to you. But you don't have anyone who has done COM programming. They probably know how hard it is because you have to deal with raw interface pointers. You have to do add refs and releases. You don't have to do anything here. Language abstracts all of that away from you, but you still get the benefits of automatic reference counting and everything. And it is exception-based, like any other modern language. And one of the great things is it is deeply integrated with STL. So you can have like collections of C++ CX types, STL collections of C++ CX types or WinRT types, and you can have collections of C++ CX collection of STL types and so on, and they interplay very well. And there are some collection types that have been implemented in C++ CX that actually builds on top of STL collections, and so that works very, very well. And anyone who has seen the syntax and somebody who is familiar with C++ CLI probably may be confused that I see hats and I see refs. So is there some .NET involved? No, it is all pure native. So there is no garbage collection, there is no virtual machine, nothing. It's pure native. You get the performance and the benefits of using native code. So here's a quick summary of the new things in C++ CX. If you're just consuming WinRT types in your C++ code, all that you need to use is these two things. This caret character, which we call hat, is a reference counted strong pointer that that does automatic reference counting and everything. And this ref new is to instantiate a new object. That's all. But if you want to create, your own WinRT classes, then we have ref and value and interface classes. Yesterday you heard about properties, events, and delegates. C++ CX also supports all of that. And you also have generics. So C++ has always had templates, right? But you cannot use those parameterized type across boundaries, across binaries. But using generics, you can expose the parameterized types across binaries. This is a very important slide. All the cool thing that C++ CX has to offer may make you feel as if, oh, let's drop everything, let's drop ISO C++ and start using C++ CX for everything. No, we are not saying that. We are saying that most of the code that you write should still be in ISO C++. All the things that you see in blue is written in pure ISO C++. Use C++ only on the boundaries. When you need to expose some functionality via WinRT objects for some other components, then you use C++ CX. But otherwise, most of your code should be written in ISO C++. Just a quick thing, again, example of how you will create a WinRT class here. So important thing here is any public APIs surface should always have WinRT types. It cannot have an STL type, for example, here. You can use STL types in the internal private things, but for public API surface, it should all be WinRT types. And this is how you're using it here. You're creating a ref new, using ref new to create an instance of person class, and this is how you'd use. And again, this slide talks about how the automatic lifetime management happens. Here, as you see, as we create an instance, ref count automatically becomes 1. If you create a copy of it, there is another, it's automatically incremented. When you finally sort of get rid of all of that, ref count goes to 0 automatically for you. And it is exception based. So you get all of these exceptions, but all of these exceptions are internally based on the H results from COM programming model. So how do WinRT components expose the API surface? You know this, that it happens through WinMD metadata, and it gets generated automatically for you. You don't have to do anything, but in order for you to use that, you can do it through 2 ways. You can add references to that WinMD file in Visual Studio from Solution Explorer, or you can have this pound using statement in your code, and you can use it. XAML, you've heard a lot about it, so I don't need to go through it again. The only thing that I want to talk about is, mention is, XAML is fully supported for C++. It has been, like, C++ developers have been looking for a modern UI framework for a long time. XAML fully supports that now. You can create your own, you can use all the rich set of controls. You can even go and create your own controls. And you have the designer. So let's see how XAML concepts map to C++. In this code piece here, you're seeing a XAML code where I'm just declaring a button, calling it, giving it a name test button, and giving it some attributes. And it has an event handler called test button click. The XAML compiler or the markup compiler in Visual Studio automatically generates the corresponding C++ code for you. What it looks like is this. You're creating an instance of the button class and assigning it to the variable test button, and you're assigning these attribute values on top of it. And then there is an event handler that is automatically generated for you. You don't even have to worry about these things. All that you have to worry about is how do you write the right code to handle that event when somebody clicks that button. Another powerful concept in XAML is data binding. So data binding, meaning you have a UI element, and UI element automatically gets data from some data source in your code. And the way you do that is you put this attribute on top of the classes that expose the bindable properties. this concept of attribute itself is new to C++ CX or C++ general. So that's how. It's as simple as that, right? And in XAML code, you just say binding path equal to title, and title happens to be this property, and it understands the data, and it automatically, dynamically updates it. I'll show you an example of that. So let's look at a demo. So I have a sort of a pre-built app which is only a little bit more than what I got from the template. What it does is, basically right now it doesn't do anything, but what I intend for it to do is load some pictures and then detect faces in it, right? That's something that you'd use C++ for. So right now it is an empty UI. There's nothing here. There are 2 buttons in the app bar, and they're not hooked to anything, so they don't do anything. So let's look at what I have here in the XAML. So in the XAML, again, you saw that in the bottom app bar, I have 2 buttons, load button and detect button. And above that, I have a grid. There are only 2 elements in the grid, this text block and grid view. I have this name called a XAML face finder here. And this grid view is called input grid view. And that is bound to the input file list. This is a property in a class in my code. Let's look at the corresponding header file. So here you see that bindable attribute, and these are the properties that we saw about. We saw it being used there. So let's add some code to load the pictures. I'm not going to type the code and make mistakes and then try to fix it. So I will just copy code from my toolbox. So let's see what I'm doing here. I am creating an instance of file open picker, which is WinRT object provided by Windows. And if you look at the IntelliSense, if you just quickly hover over it, it tells you clearly what is it. It creates a new instance of file open picker. But if you want to inspect it more deeply, if you do go to def on it, it opens that in object browser. Object browser is a very useful tool. It allows you to inspect the namespaces and types and everything here. And you can see good descriptions of different methods and different types here. Okay. So I'm creating an instance of OpenPicker, and I'm assigning some attributes to it, and then I'm calling a pick multiple file async function, and putting all of that in a task. And then when it happens asynchronously, and when all of that happens, I then follow by a lambda and use the .then syntax to do that. So if you wanted to do that, the task is a sort of new async functionality that has been built on top of PPL called Parallels Pattern Library. So if you were to do this without the tasks and PPL, you would have to write a lot of code. So using this, you can do that very simply. So let's run this again. So what we are now going to see is that if I load, I see a bunch of pictures, and I can select it, and I can load it, right? So this is great. So what was the point of that demo is writing that kind of UI in C++ used to be extremely hard. You'd have had to write do a lot of code. And here we were able to do that in a few lines of code from the template. No, it's so easy, right? So now, but that just means that it's easy to do the UI, but that's not why you would use C++. You would use C++ to do some heavy computation. So I want to now detect faces from those images and take it out. Now, I'm not a image processing scientist, so I don't know how to do all of that. There are libraries that are built out there. I would like to use that. So some of you are probably familiar with OpenCV libraries. They're very good at these kind of things. So I will use a open source OpenCV face detect library and use it in my code. And I'll show you how simple that will be. So the way I do that is I will add a reference to like this, and I have something called an extension SDK. So Visual Studio has introduced this new concept called extension SDK. So the way, if you are a library vendor and you package your library as an extension SDK and you publish it in VS Gallery, I as a developer can consume it, and Visual Studio will install it in such a way that it shows up in this place. So it's very easy for you to consume it. You don't have to go change the configurations or SDK path and all of that. It's as simple as that. Of course, it is not available publicly. We have created it for this demo. So I hit OK. OK again. So now I want to see what is in that SDK that I just referenced. So now Object Browser shows me that WinRT component that I just referenced here, and it shows me that there are just 3 functions: extract faces from file asynchronously and search files, and so on. So I will now use that in my code. Again, of course, I'll copy it so that I don't make any mistakes here. So what I want to do is detect faces from the images and then put it in a separate grid down below the grid that I have. But I don't have that UI. So let me just add that UI here. So all that I'll do is copy this grid view. Let me just use this thing that I already have pasted. And in here, I go and paste some more code. So let me show what I'm doing here. So I'm now using this WinRT component from this third-party library. Again, the IntelliSense tooltip shows you that. You can go into the object browser and see it. So it is just as easy to consume as it was to consume a Windows API, for example. And again, I'm using this, calling this asynchronously and putting this in a face list, face file list. So let's build this again. Takes a little bit of time. So what have we seen so far? Let me just load some images, select all, and now I have this detect face. It is detecting faces and asynchronously populating those faces here in this lower grid. If I can select these things, and I would like to do some more things. Share. Right now nothing happens, right? So I'll show you in the next step how do I do that. But so far, creating UI is simple. Using a popular library or external library with external powerful library in your code, very easy. And so leverage your existing code or external code for compute and use it in your XAML app. So let's make it a first class Windows Store app. So let me add some more code to enable share contract. So here again, I'm hooking into the existing operating system support, and with very few lines of code, I'm able to show the functionality of how I use the share contract. So let me show you. Do that again. Detect faces. Let me select this Mac guy and PC guy, and I want to share it. Now I can share it in an email. Okay, so these two faces are here. Let me send it to myself, and I should get that picture in some time. Okay. All right. So I'll stop this demo here. So again, to summarize. Creating UI is easy, consuming external powerful C++ library is easy, making it a native Windows Store type experience, easy. Okay, so that was that demo. So now you can. We have a similar version of this demo where the UI is actually not XAML C++ UI, but it's HTML5 JavaScript UI, and the same component is used there also. And integration is so nice that you feel if you're writing JavaScript code, you'll get IntelliSense for the types that are coming from C++ component. And the project system and the IDE, all of those things make it very easy for you to do that. And a lot of apps that are in the box right now are using these kind of technologies, the hybrid technology, JavaScript for HTML5 JavaScript for UI, and C++ code behind for compute. So these examples, these are some of the examples. So mail, messaging, people, all of these apps that Microsoft has built. Again, you can reference the WinRT component, C++ WinRT component from a JavaScript app in the project by doing project-to-project references. And you can use extension SDK mechanism, and you see both IntelliSense in the mixed and yes. Yes. So let me repeat that question. The question was, are you saying that you in the same application you have JavaScript HTML5 code and C++? Absolutely, yes. I was told that I should save the questions for the end because we are running a little bit over. So I'll try to make sure we have time. So that was the Windows Store app world. But the real thing, real reason, real bread and butter that C++ is bread and butter is power and performance. That is why people use C++. And more these days, power and performance heavy computation generally means parallelism. We still do very good optimization for your straight single line, single threaded straight line computation. But even if you made that infinitely fast, you're still wasting a lot of power that is available to you. The multiple cores, the vector units of those, the cores, and then GPU, everything. So let me. I'll talk about a few specific technologies that we have added in this release that help you achieve parallelism. Again, going from bottom, we saw the PPL algorithms, task then, std async. These things help you with sort of task parallelism and making sure that your app remains very responsive and embodies the fast and fluid design principle of Windows Store apps. Another thing is auto-vectorization and parallelization. What we do is we go through the compiler, analyzes your code, and figures out if there are some parts of your code, some parts of your loops that can be automatically parallelized, as in put on different cores. And the second part it does is if it tries to check if it can generate code that will target the vector unit of the processor. How many of you are not familiar with what is vector unit? Everyone knows, right? So I'll not talk about it much in more detail. The best part is all of that is free. You don't have to do anything to get that performance. Just use the new version of the compiler and you get it. And the third thing is, now that you've used all the power that was available to you on the CPUs, how do you leverage the GPU that is also available on the machine? You use that. You do that via C++ AMP. C++, I'll talk about that in a little bit later. So I'll skip this part. Let me show you a quick video that shows the power of auto-vectorization and parallelization. So here, let me. So what you see here is a simulation called ray tracing simulation for people who are familiar with this, it basically simulates the rays of light reflecting from real objects. And then on top of that, it does some blurring operation. So it has to figure out of all of these points, which ones are in the direction of the source of light, and then it has to do blurring over there. So it basically is some sort of operation on a very large set of data. So heavy compute happens here. And if you look at this, we have written this code in, this is 2010 version of Visual C++ compiler, and so you're getting about 1.5 frames per second, and the CPU is not getting utilized very well. This was run on a 40-core machine. Okay, so now if you just rebuild this machine, this app using the latest version of compiler, and you run it again, that's what I'm doing here. So now you see that you're getting about 16, 17 frames per second, and all of your 40 CPU cores are getting utilized. Of course, this was a demo app which has been optimized, written in such a way that it shows the maximum benefit of that. Your mileage will vary, of course, depending on how much vectorizable loops the compiler can find. So, but all of this, so you're getting like 10x performance benefit without doing one character change here, one character code change here. And all of that was achieved by just vectorizing this one small loop in this sample app. Okay. Let me close this. So that was the power of vectorizer and parallelizer for you. Now, the next thing is C++ AMP. Let me do a demo a little bit later. So I will read this one statement here. What is C++ AMP? It's a programming model for expressing data parallel algorithms and exploiting heterogeneous systems using mainstream tools. Mainstream tools is important here for productivity, portability, and performance. All right. So what did I just say? Just using C++, you can write code that will run on GPU card. For that, right now, if you want to do that, you have to write, say, CUDA, for example, and acquire a different set of tools and language for essentially what is just a very small portion of your code, the data parallel portions of your algorithm. So what you get is you can be very productive writing. You want to leverage GPU or the graphics processor units and write code for that, but you are very productive because you can use Visual C++ and Visual Studio, and you don't have to learn a lot of new concepts. And you get portability because it is built on top of DX11. So wherever DX11 runs on any GPU card, your C++ AMP code will also run on it. And what we have also done is we have released this as an open spec. So any other compiler vendor can also implement that. So your code, if they end up doing that, your code will run on that also. So you get the performance benefit because, of course, all these GPU cards can run your code. So I will show you again a video that does that. So here what I have again is a simulation of N-body, famously known N-body simulation, where it shows the interaction of N number of bodies under the gravitational force of each other. So right now you see the single core, it's running in single core, and you're getting about 2-3 gigaflops, right? There is a multi-core version of it using PPL, different code path. Here you see that we are getting a better performance, but all your CPU cores are getting pegged now. If I want to conserve my CPU for something else and still get different benefits, I can. So basically, let me explain what this kind of. So this simulation is basically running large set of same computation on a large set of data, the data parallel algorithm, right? So this is a very good candidate to be offloaded to GPU. So here what we have done is different code paths where using AMP, we are offloading that computation on a graphics card, and you are getting 300 gigaflops. And there is a different model called AMP tiled model, where there is additional memory sharing efficiencies on the GPU, because of which you get even better performance. So close to 1 teraflop now, right? So we're talking about game-changing performance here. But it gets better because it is portable. It can use multiple GPU cards. So this machine had an NVIDIA card and an AMD card. And the same app, same code is running on both. And you are getting performance. And you didn't have to write differently for different GPU cards. You got that portability because you wrote C++ AMP code. And you're getting 1.5 teraflops here. So again, using this AMP, you can get substantial performance advantages. So now you ask, sure, I get that performance, but how hard it is for me to write that, and how do I get that? Let me show you a simple code example. This is the CPU version of that code. This is hello world example, right? It's an array, and there are characters in that array, and I'm adding 1 to each character, and then finally when you print it out, it will be hello world. So if you want to write an AMP version, you of course have to include the AMP header, and if you want to do less typing, you use the using namespace concurrency statement. This is a data structure in that AMP header file, which basically copies the data that it wraps the data that needs to be sent to GPU, because it's in a different chip, right? It's a discrete card. And then I change that here to use that same wrapped data. And then parallel for each is the entry point for that computation. And I'm giving, instead of 11, I'm giving it an extent of that, the data that is being sent to GPU. And this one thing here is telling the compiler to make sure that whatever is inside this lambda can run on GPU. There are certain things that GPU does not understand. For example, GPU does not understand chars. That's why I'm using ints here. So again, at this point, that's all you have to change. It still looks very similar, almost like your existing C++ code, and you're able to target GPU just by doing that much. So what does all of that provide us, the benefit? So this is an Ivy Bridge lithograph or processor's image. You see 4 cores here, and a lot of real estate given to the integrated graphics processor. Using Visual C++ 2012, you can target all of that real estate, almost everything other than the cache, for your C++ Windows Store app. The amount of juice, computing juice that you have available to you, all of it can be used, right? So let's see how did we use different portions of that technology in Austin. So let's go back to that demo again. So first of all, this is based on direct 3D, so you get this 3D impact, right? All of this fast and fluid experience is coming because we are using async, right? So what happens is we store the sort of the thumbnail images of these pages, and that's what you're seeing. And when the pages, actually the full images, load asynchronously. So you still get that responsive experience, even though it has to load a lot of data, right? So when I do this page curling, page turning thing, people familiar with graphics applications know that internally it is a set of vertices and triangles. So it has to calculate the relative position of all of those vertices and triangles relative to this axis here, right? And it does it so fast because it is using the vectorized loops for that. And the 3D effect, the shading, again, it's the same thing. It has to calculate the normals of those triangles and then calculate the angle difference between that source of light and the normal. And it does that very fast using GPU. And so it is able to do that very, very in a performant way. Let me write something. So if I do this, what's happening is it is using digital ink, and the lines are very smooth. And the way it happens is it samples the points as my stylus moves on the screen, and then it has to. There are discrete sort of points on the line, but it figures out an envelope around it, and it does that again very, very in a very fast way using the vectorizer. So if I turn that off, let me see if you can make out on this. If you notice here, there are sharp edges, and if I turn it on and off, you will see the difference, right? So all of that calculation to smooth it out is being done real time as I draw, and that is being done because of the vectorized loops. In this animation, let me show you. We have built some instrumentation in here. So again, this shading and this effect is used. The lot of normal calculation is being used to figure that out, and that is being benefited by using AMP. So let me show you what happens. What impact does it actually make? So right now, actually, AMP is disabled. So notice in this graph here, the normal calculation says about 5.7 per calculation on an average. If I turn it to true, it goes down to 1.1, and you can actually perceive the difference in how fast the animation becomes. So notice the drop down here. Okay, if I turn it back off, it'll go up again. So if you care about this level of performance, and the technologies like C++ AMP, vectorizer, async, all of this will help you create all of that experience. Right? So let me close this. So in summary, Visual C++ is first class, more than first class citizen of Windows Store world, and it supports all three kinds of presentation technologies, and you have access to the full hardware power that modern day tablet machines have to offer. So use those things and go build stunningly beautiful C++ apps, Windows Store apps. At this point, I'm open for questions if you have any. And we'll be around afterwards also. Tariq from my team is also here. So we really want to talk to you guys. iOS developers are, we think they're the ones who would be very interested in C++ type apps. So if you have any special issues that you'd like to talk to us about, we'll be here till late. So any questions? The compiler is same, yes. Yes, everything. The AMP. Okay. So he's asking if I write an app that uses all of these technologies, and that app is running on RT device, will I see the same benefits or not? All of those things will benefit. AMP has with some limitation. There are some limitations on AMP. AMP doesn't work fully well, but we're working on that. But vectorizer, parallelizer, all of that, it's the same compiler. It works fine.
What about the phone? Will that stuff? Does all that stuff work on the phone?
So AMP does not work on phone right now. Is it on the roadmap? Sorry? It is on the roadmap, yes. I do not know when we'll get there, but it is on the roadmap, yes.
You just mentioned mixing the JavaScript and C++. So is there any JavaScript runtime engine interpret the JavaScript code in runtime, or how you do that?
So let me make sure. If I understood your question, you're saying, can JavaScript and C++ code run at the same time, and how is it done by, is there a JavaScript runtime that is doing all of that magic? Mm-hmm. So JavaScript runtime is doing the magic that makes it run on, for WinRT, but there is no special magic required for it to work for C++ WinRT component DLL to work for it. Visual Studio is doing some plumbing for you.
So you're saying you convert the JavaScript code to...
Oh, okay. Now I think so the way it is happening is because they're both talking to each other in WinRT API. So that is the beauty of Windows runtime APIs. So JavaScript understands that API. WinRT component written in C++ exposes those APIs. So JavaScript code is actually consuming WinRT APIs. That's how they are talking. The Java runtime, that's a separate thing. Any other questions? If not, that's all. Thank you.